Good morning, everybody. It's fantastic to be back here for a second year in a row and to celebrate 4 years of the event. Geen, I had the great pleasure this morning of actually coming here on a bicycle from the hotel, so I managed to do it. And indeed, it is a great pleasure to be able to do it. We come here every year and we talk about how software is changing the world. And it's sort of worth recalling just how significant some of those changes have been just in the last year. As my colleague from NetApp commented, you know, we've had a year where Tesla's market cap overtook that of Ford's. We've had a year where the CEO of Ford, Mark Hurd, who actually I had previously worked with in a previous role in the world, was replaced by the head of self-driving car development. So a marketing exec is replaced effectively by a developer at the head of one of the world's largest car companies. We've seen Airbnb reinvent the hotel business. We see Uber reinvent taxis. This is happening all around us. I will talk in a minute about a project we're doing with one of the world's largest pharmaceutical companies. And we've often talked about big pharma, but in fact, big pharmaceutical companies now talk about themselves as big software companies. And what I want to talk today about is a little bit about how we help everybody make that transformation to leveraging the value they have in their data and to getting access to compute, whether that be in private or public cloud, and hopefully revealing some of the magic that enables that to happen. So we're on, would help. There we go. So I just want to talk about some trends to start off with, because at Canonical we have the great privilege of working with companies like Netflix and Google, Airbnb. It's all based on Ubuntu. And yet I think the question is, for many people in the room, is how do I take those trends and actually make them relevant to my organization? Like, I'm not an Uber, I'm not a Google, but how do I make it actually relevant? I also have lots of I don't like the word legacy, because the reality is I have lots of applications that are up and running the business. How do I think about transformation? And I want to talk about 4 trends that we see in the projects that we engage with here in the Netherlands and across Europe. So firstly, I think we have to accept we're now in a world of hybrid cloud. There is not an organization that we work with that is not both on multiple public clouds and also on multiple private cloud instances. Even companies like Dropbox and Box run private cloud infrastructure. So I think the first thing is to accept, as leaders in our organizations, we live in this hybrid cloud world. The second thing to accept is all private cloud initiatives in your organizations are going to be relentlessly financially benchmarked against public cloud. So even if you have a security reason, a data protection reason, or whatever reason, a network topology reason why you can't be in public cloud, there will be a huge focus on the economics of your private cloud infrastructure. And that economics is not just reducing the price, it's pricing as you go. How do you reflect to your organization that as people consume compute, they pay for it, and how do you make that transparent to the organization? There'll also be, in the private hybrid cloud scenario, this question about how deep do I go on any one public cloud? Like, what is the level of the APIs I'm willing to use? And if you don't have corporate rules about that, then you're sort of allowing development to go on without thinking about what the long-term costs of being on a single vendor strategy are. So I think that's some basic things to think about in the hybrid cloud world. We see this relentless appetite for containers, clearly, and I absolutely agree. I think this is part of a journey to containers and then eventually to serverless or function as a service. But some things that stick out very clearly for me. I get asked a lot by large organizations, hang on, we are doing platform as a service in the organization. I'm doing Cloud Foundry, or I'm doing Pivotal Cloud Foundry, or I'm doing Red Hat OpenShift. Surely that is my container story. And the answer is it's not. We see in all the organizations that have gone out early on PaaS that they are also offering container as a service. On one side, a very structured monolithic platform as a service is extremely good for some back-end applications, and maybe 80% of your application development will move to that. But for the applications where the developers really need to go quickly, where you have real competitive advantage as a business, that will happen on a service that will be based on a full Docker stack or a Kubernetes stack. And in fact, in the very largest organizations, as some of the big banks that we work with, we in fact see a central PaaS, as well as a couple of container as a service offerings being approved internally. So it's, there is a battle going on between a full Docker stack and a Kubernetes Docker stack and a Mesosphere stack. At Canonical, we offer a full Docker stack and a Kubernetes on Docker stack. So we're sort of supportive of both, but we actually are seeing large organizations purposefully make the decision to do both. A couple of other things I'll sort of just reference here. There is the continual move forward of new workloads. We work, obviously, things like Ethereum, blockchain, looking at how AI, TensorFlow, higher level frameworks like Keras that actually make TensorFlow more accessible to organizations. And I think they fall into the type of project I talked about here last year, which is this final problem of big software. As a CIO, as a CTO in the organizations where you work, you're seeing more and more complicated software, and the question is, how do you make it consumable in the organization? And the answer there is, you have to move to service modeling. It is the only way to make this ongoing tsunami of new technology consumable by the organization. Okay, so, going back. So, Canonical, there's 600 of us around the world. Our mission is super simple. We're trying to bring the innovation of the hyperscalers and make it consumable by ordinary organizations, allowing you to go faster with better economics. And that better economics is that utility economics I was talking about earlier. Your private cloud has to beat the economics of public cloud, otherwise it will not exist in 2 or 3 years' time. Obviously, that's by our role here. Some people aren't familiar with Canonical, is to provide technology and services. And for that, that is both support and increasingly managed services. We started, and I have to thank Ben and Ruud for their support 3.5, 4 years ago, offering managed services around OpenStack. That need to offer managed services is only growing. In fact, we're taking over one of Europe's largest banks at the moment, their private cloud infrastructure, and running them for it. The huge advantage to all of our customers is that we're learning about the operational economics of private cloud. Like, operations is where the money really is, and we need to drive that cost of operating infrastructure down. A couple of case studies around OpenStack. We talk about OpenStack in production a lot. This year, we've now started working with AstraZeneca. All of their future research is now being done on bare metal cloud and on OpenStack. So we found ways of taking high-performance schedulers and integrating them into OpenStack, and then making that available to developers within AstraZeneca. Another really interesting project is taking the telematics cloud for Verizon that runs the whole of Mercedes-Benz North America and building that out on a modern container infrastructure. So again, taking new technologies, then working in worlds of lots of integration, having to work with existing infrastructure, very strict security frameworks. That is what the team on the ground are doing. So let's talk about OpenStack specifically. We continue to think that the real challenge with OpenStack is operations. We have been making operations super easy. And what we'll demonstrate a little bit in a second with Chris is the ease of installation of OpenStack. Last year, we demoed the ease of upgrading OpenStack. One of the challenges we see in the field is what we call stuck stack. People get a cloud out there, but are finding that they can't upgrade it. And we think that the key to that is automation. So everything that Canonical does around OpenStack is around automating the operations of that cloud. And then my other point here would be that focusing on containerization of the control plane of OpenStack. This is something that we did 3 or 4 years ago. It's now coming back into fashion. Like, we were out on our own for a while. But as you try and make OpenStack work in small settings, having the control plane fully containerized both allows you to operate it in smaller environments, but also to make the upgrading of that in small environments possible. Some updates. Who here, I'm sort of curious, which versions of OpenStack are people on? Is anybody on a Carter already in production? A few people. Anybody on Pike yet? No. Okay, so the good news, yes. The good news is Pike is out. It's Ubuntu, all the charms and all of the installation for putting Pike into production is now available. We had it out in early September. You'll see improvements with Novel XD giving you bare metal performance, so you can take a whole machine and instead of having a KVM hypervisor take some of the performance out there, you can actually use it with a full machine container. You'll see Ceph Luminous, which is a huge leap forward in Ceph, available in Pike, notably with an improved dashboard and improvements on DPDK and NUMA support, which if you're a telco, if we have anybody here from KPN, that's going to be a significant improvement for very high performance use cases for network throughput. A couple of other big updates. Who here is using kernel live patching in production? Anybody? Not yet. So 1604, Ubuntu 1604, we now have live patching the kernel. That means when we release critical security updates to the kernel, you do not have to reboot machines. This is hugely beneficial. One, it allows you to make sure you're applying security patches without taking the cloud down, and it meaning that security patches get applied quicker. And to the earlier point about gender representation in OpenStack, you'll be glad to know that the head of kernel engineering, Leanne Osagara, is the young woman who leads all the engineering for the kernel at Canonical. The other big news on the security side I want to raise, the Ministry of Defense here in the Netherlands has long used Ubuntu for the backup for communications and compute within the ministry. We've just had the whole of the platform certified with FIPS in North America. So that, again, from a security perspective, the story is only getting better. Right, let's get to the topic of magic. So one of the magics I think you may have experienced with Linux was the ability to install a whole operating system yourself onto your router and get going. And I wanted to introduce Conjure Up, to conjure, to put a spell out. Conjure Up. Conjure Up is our new recommended way of installing big software. So we're taking complicated software like OpenStack, like Kubernetes. And I wanted just to show folk how easy it is to get OpenStack up and running now using Conjure Up and giving you some freedoms about the journey you want. So Chris MacNaughton, who's part of the OpenStack engineering team, do you want to sort of talk us through what you're doing here?
Yeah, sure. So Conjure Up is this new tool that Chris was mentioning. Let's run it. So we've got two different options here that Conjure Up presents us with, Nova KVM or Nova XD. You can mix and match, but with this tool, you get one or the other. So let's do OpenStack with Nova KVM. Let's not do OpenStack with Nova KVM because I can't deploy it on this cloud.
So what we're going through is a simple wizard that's taking you through a set of decisions to get OpenStack up and running. Is that correct?
Indeed. Except when you're trying to do it on a somewhat restricted cloud. So let's do it on Amazon. Or my local machine, probably.
I'm feeling like an Apple exec with the face recognition not working right now. There we go.
Still don't have Maz.
It's maybe the issue of leaving the laptop up here for an hour. Go a second.
All right. So we're going to configure the network bridge that LXD will listen on.
Okay.
Now, we can see the OpenStack services you're used to seeing. We've got Ceph, both the monitors and the OSD nodes. We've got Redis Gateway, Glance, Keystone. We also have LXD to manage the Nova LXD hypervisor, all the various networking and compute services you'd expect. In here, we can actually go in and manage them. We can look at the configuration. We can change authentication, do all sorts of somewhat more advanced configuration for these services. We can choose how many units we have. So you want to have a larger cloud. You want more Ceph OSD units deployed? We can do that. When we're ready to actually go, we can deploy them.
Okay, so what's going to happen now? So we've taken an OpenStack bundle. You've been allowed to make a set of choices for the installer, and now it's going to go ahead and do an installation on AWS. Now that's
This
going to
one's
take...
actually on LexD. This is locally on this machine.
Okay, so locally on this machine. Now that's going to take some time to do the full install. And so while that's going, and we'll show it live at the end, if you do a reboot, I want to talk about containers. So making OpenStack easy to install is sort of the base, the starting point. The question then is, what do you want to run on top of it? And what I wanted to talk about today was getting Kubernetes up and running. Who here is getting Docker or Kubernetes as a scheduler up and running in the business? Hands up. Who has demand from developers for Kubernetes that they haven't yet in the business? Starting to see it. Okay, I'll make a prediction here. So what is Kubernetes? Kubernetes is effectively a scheduler for lightweight containers, process containers, so a Docker environment. It is the way that all modern product development will happen going forward. When you hear about cloud-native workloads, they are going to happen using either Kubernetes or a full Docker stack. The really useful thing for many businesses is that Kubernetes is emerging as a great... You can run Kubernetes on AWS, and you can run it on OpenStack locally or on bare metal and on a Microsoft cloud, and it becomes the same base environment that your developers can target. So you say, we've got environments up and running in these multiple clouds, but what they're actually writing to is they're writing Docker containers that will run in a Kubernetes environment. It's a project started by Google, and it has the most momentum we've seen in any open source project in the last 10 years alongside OpenStack. Okay. Releasing every quarter, and it's the product that Box, Dropbox, Google themselves use to run services at scale. And the beauty is you can run, frankly, it on your laptop all the way through to then running it on a large cloud. And it deals with the life cycle of the container. So how to start it, how to scale it, how to do health check, and self-healing of the container. So the question there is, how easy is it to get Kubernetes up and running? And what we'll show when we're back on screen
Almost back up.
is of an install of Kubernetes then on a public environment. With Canonical Kubernetes, the goal here is to give you an upstream version of Kubernetes. So you're seeing pure, just like if you think about OpenStack, how many people here are using Ubuntu OpenStack as their base? It's a base, yeah. Okay, so if you think about why do you use Ubuntu OpenStack for OpenStack, because you're getting pure OpenStack immediately after the release. The same is true of Canonical Kubernetes. You're getting pure Google Kubernetes immediately after the release, and with an ability to upgrade and manage that. Okay, so do we want to go back into that Kubernetes journey? And then bring the deck up as well. Okay, technical demos, huh? Yeah, sure. Okay, so we'll do a demo. We'll do a demo of the Kubernetes in a second.
Yeah.
But yeah, okay. Go ahead.
Is there already a question? Because I have a few, but you need to come on. I have to correct you with the router. It bothers me because of your bike ride, it is, I think. I actually took a 386, I don't know who remembers what that was, and then built a router on it, software on it, took off the monitor, screwed it on the wall, and it worked. So I'll come back to this story, I think, about 5 times in
I think you should have a medal for it as well.
Thank you. We'll see in the end. You explained about, if I understood well, about the challenge between the public and the private cloud, and that there will be looked at from an economical side of view.
Yes.
But that's a very rational way of looking at it, I think. Isn't it true that it's also an emotional part? Because my experience is when I come to a large corporation or a hospital, for instance, if we talk cloud, it's immediately like, ooh, is that safe? And no, rather not. And we have our stuff here, and no, no, no. So you don't even come to the economical part. Is that something you recognize, or is that an old way of thinking?
There will be some environments, for whatever reason, where it won't go to public cloud. But I increasingly think, even where there are those reasons, that will not stop there being a very harsh economic spotlight on the project.
So, and they will become visible on the spreadsheet in the end.
Yeah. Now, there are good reasons. Look, we know telephone networks can't move to the public cloud. And as you said, the hospitals. We see large data sets. I mean, one of the issues here is data gravity, that sometimes you have very, very large data sets that just aren't that transportable. And so it's easier to bring compute to the data than it is to bring the data to compute. That is particularly common in a pharma use case. So there are lots of good reasons to have private.
Yeah.
I think...
But that's a good reason, but
yeah.
not an emotional reason. That's a good reason,
Yeah.
okay?
Yeah. So we see both.
Okay.
Any other questions?
Are you set up already? I cannot judge it.
Mm-hmm.
Okay, so yeah, thank you. So thank you for stepping in there. So we were going to take the step up of Kubernetes. So conjure up Kubernetes is exactly the same journey, where we are able then to say, I'm in a terminal, I want to deploy Kubernetes. So we have two options here, and Chris, maybe you can explain the difference between the two.
Sure. The Kubernetes core in this spell is a much smaller deployment. It's 2 machines. It is not highly available, but it's very effective for testing and development. It's minimal. It does have the full setup that you need. etcd for the cluster management, the dashboard, your workers, your master, even Flannel for your overlay networking. The canonical distribution of Kubernetes, on the other hand, actually has all of these same features, but in a highly available setup. It includes the Kubernetes API load balancer that we'll see in a moment. As you see, we can deploy this one on many clouds.
So hang on. So you're able to take the exact same this is really critical in a hybrid cloud story. You're able to take the same Kubernetes, and there we can deploy it to AWS, Azure, Google, Oracle, Rackspace, or OpenStack.
Mm-hmm.
Okay.
The server stack is the Ubuntu OpenStack Engineering QA cloud that we use to validate all the OpenStack engineering prep.
Okay. And then, if we can zoom out a little bit, you maybe explain some of those services. So I see there we've got EasyRSA, etcd, and Flannel. Can you maybe explain to folk in the room what those are?
Yeah, sure. EasyRSA is used to give us a shared CA, a certificate authority, to allow for us to safely encrypt all communication between the various nodes. So any worker to master communication, communication between the dashboard, all handled seamlessly, encrypted by default. etcd is the primary data store for Kubernetes. And Flannel is an overlay networking that lets us network all of the containers on any number of worker nodes seamlessly on any substrate. Metal, OpenStack, public clouds.
Okay. Great. And so again, if you start that'll take about how long to do the install?
15 minutes.
Okay. All right, so if we can go back to the presentation, so thanks very much, Chris. So the point there is you've got, just as we've had the ability to do a simple install of OpenStack, Kubernetes, I guarantee if you're in a large or medium to large organization, Kubernetes will be something you will be asked to deploy in the next 12 months by your developers, guaranteed. And if you are looking for a cross-cloud story, management story, then Kubernetes in multiple public and private clouds is an extremely good story going forward. That is a product now available. It's, that journey is open sourced. You can get up and running without contacting Canonical. If you want some support on that journey, then you can, let's skip forward. We offer a couple of commercial packages that are also available via Fairbanks, so Kubernetes Explorer and Kubernetes Discoverer. Okay, so these are two pre-packaged bundles of consultancy that help you get Kubernetes up and running in your environment with integration to your existing ID management, storage setup. But we think that's a great way of accelerating the adoption of Kubernetes in organizations. So, I started this talk by saying our role at Canonical is to help you go faster, to help you innovate faster as an organization, and to do so with utility economics. And I just want to sort of leave on that note, whether or not you're doing OpenStack and you want to run it yourself, whether or not you want to have managed OpenStack through a partner like Fairbanks or directly through somebody like us, or whether or not you want to get Kubernetes up and running, we are here to guarantee that you can get these environments up and running, that you can do them with predictable pricing per day, so that you know exactly what it's going to look like over a period of 2 or 3 years. And we'll guarantee uptime. Now, we're taking the responsibility for making sure that that private cloud infrastructure is genuinely up. And we think that enables everybody to go faster. Thank you very much. Questions from the audience?
Quick question. Otherwise, you have to. I mean, I'm sure you're around. You too.
Yep. So we'll be around on the booth, and then we've also got a talk this afternoon around Nova LXD and getting bare metal performance out of OpenStack. And I'll be doing a separate talk more on a business level about what microservices, AI, and other new software, what it actually means in terms of planning in organizations.
So plenty of opportunity to catch one of the Chris's. So thank you both.
Thank you very much for your time.
Thank you.